Dear friends, you know very well that in case of the matter waves, the quantity that varies periodically is the height of the water surface. And in sound wave, it is the pressure. And in case of the light waves, electric and magnetic field that vary. Now, the question is, what is that varies in case of the matter waves? You know the wave function, you know very well about the Sirhindi equation, and there's a function psi. That's the Sirhindi equation is very important equation in the quantum mechanics, and in the Sirhindi equations there are partial derivatives and the Planck's constant. Now what about the wave function? And this wave function, how it gives us the shape of the wave, that's the question. And again, the wave function is a complex quantity. Is the wave function is large, where there is a greater probability of finding the particle? This is a question for you. And is the wave function is small, where the probability is lower? Think of it. And what do you think? Either wave function is observable or not. And it is the fact that no one will ever see the wave function of a particle. So in that sense, it is not real. Again, there's a question mark. But we can see the probability distribution, which is the magnitude of the wave function squared, means psi star psi. It seems as the only way to properly determine the probability distribution, okay, and the time evolution of the observable is through the consideration of the wave function. So in that sense, that it directly affects what we observe. The wave function, can be thought of as the real thing. I guess the best way to think about it is something just below the fabric of reality that helps the shape of the fabric. Now, some points are: number one, you cannot ever observe the wave function. There is no way of detecting the wave function of a particle or of a system. Number two, the wave function is not a unique. There is several and infinite amounts of equally good wave functions that describe any system. Okay. So these 2 points, together spells like the wave function is not real. But I think this does not mean, however, that there exists a better description of nature than the wave function. This is the same kind of argument like the magnetic vector potential. It is useful tool when calculating the physical things, but it is not physical in it itself. So mathematically, the wave function is not real because it's a complex function. You cannot measure it directly. You have to square it first to get some probability distribution that you can verify experimentally. Since you cannot directly measure the square root of a probability density, so it only becomes something physical once when you square it. And lastly, the physical significance of the wave function. First of all, keep in mind the wave function psi has no physical meaning. It is a complex quantity representing the variation of the matter wave. The wave function psi, which is a function of position and time, describes the position of the particle with respect to the time. Now, third, it can be considered as probability amplitude, since it is used to find the location of the particle. The square of the wave function gives this is real and important. The square of the wave function, that means psi star psi, gives the probability density of the particle, which is represented by the wave function itself. More the value of the probability density, more likely to find the particle in that region. Okay. Now we are having the different type of wave function, like I'm giving in the description. But the main thing is, what do you think about the wave function? You give some new idea about it. That will be very valuable, because still we know the psi star psi, which is a probability density, but psi itself, it is a complex quantity. So this is a question for you, how you give some physical meaning to a wave function. Okay, thank you.